Your subscribe keeps us motivated. Subscribe now.
A bullet of mass 10 gram. So let me write here, mass of bullet here is 10 gram. Moving horizontally with the velocity of 400 meter per second. Strikes a wooden block of mass 2 kg, which is suspended by a light inextensible string of length of the string here is 5 meter. Okay, fine. As a result, the center of gravity of the block found to rise a vertical distance of 10 centimeter, that is 0.1 meter. I am just converting it in the standard unit. The speed of the bullet after it emerges out horizontally from the block will be. Okay. So that is quite interesting. What is happening here is there is a string, and to this string there is a block attached, wooden block is attached to here. Okay, and when you are hitting it, okay, it is struck by the strike. Okay, so it is struck by the bullet. So bullet is going and hitting this block, and the center of gravity is going a little bit, it is changing its height. Okay, so we have to find the speed of the bullet after it is emerging out. So this is straight away we will make use of our conservation of momentum. But before that, let's see what are the other things we have to find. So from the conservation of energy, if it is an elastic collision, okay, from conservation of energy, what we can say that potential energy at the maximum height, okay, maximum height achieved by this block, maximum height achieved by the block will be equals to the kinetic energy at the bottom of the block, correct, by the law of conservation of energy. Now that will be how much? That will be our m, let's call it as m, okay, m, capital M, G, H, and that will be equals to half m v square, right? Okay, so v I have taken for the bullet, so let's call it as v2 square, right? Now v2 from here will be square, will be equals to how much? M and m cancelled both the side, 2gh. So velocity v2 will be equals to under root 2gh, correct? How much height is attained by this? 2 into g, g is 9.8 into h is 0.1. So that can be written here as 2 into 98 into 1 by 100. So 2 into 98, 196, and root of 196 is 14 divided by 10, which is 1.4 meter per second. So this is the velocity of the block when it reaches to that particular height, correct? Now if we use the law of conservation of momentum, so from the law of conservation of momentum, okay. Initially the block was at rest, so m1, which is the mass of the bullet, into u1, correct, and that must be equal to m2, which is the mass of the block and its velocity, plus m1 v1 velocity of the bullet, correct. So v1, we have to find the speed of the bullet after it emerges out horizontally from the block. They are asking v1. So we can take here m1 u1 minus m2 v2. That must be equals to m1 v1. And v1 will be written here as m1 u1 minus m2 v2 whole divided by m1. m1 is the mass of the bullet. So that is 10 gram, 0.01 into the velocity here is 400 minus mass of the block 2 kgs into the velocity we just now found 1.4 whole divided by m1, mass of the bullet 0.01, correct. So let's see how much we get. So this will be 4 minus 2.8 whole divided by 0.01, correct. So let's see how much we get. So 10 minus 2, 8 is 2, and 3 more, 1.2 divided by 0.01. When you remove this point, you will get here 10, and when you remove this, you will get 100, and we left with how much? 120 meter per second. That's our answer. So correct answer is option C, 120 meter per second.